What's going on, everybody? Welcome back to my YouTube channel. We have this nice Olympiad question here on the board that we need to unravel. And the question says, if s to the power of 2 minus s to the power of 3 is equal to 12, find s. So now let's write the question here once again. We have x to the power of 2 minus s to the power of 3 equal to 12. Now we need to do something to this 12. We need to look for two numbers to add to give us 12. And one of these numbers must be a perfect square and the other one must be a perfect cube. What is that number? Come to think of it, 4 and 8. 4 is a perfect square and 8 is a perfect cube. And when I add these two numbers, they are going to give me 12. Cool. That's cool. So we are going to be using 4 and 8. So I have x to the power of 2 minus s to the power of 3 equal to, now we use 4 plus 8. There you have it. There you have it. So now we have s to the power of 2 minus s to the power of 3 equal to, remember we said this is a perfect square, right? So that means 2 to the power 2 will give us 4. Plus, and this is a perfect cube, which is 2 to the power 3 will give us 8. That is it. So now let's move everything on the right to the left hand side. So we have x to the power 2 minus s to the power 3. When this 2 to the power 2 crosses to the left, it becomes minus 2 to the power 2. When this 2 to the power 3 crosses to the left, it becomes minus 2 to the power 3. Equal to, now we don't have anything on the right, so we equate everything to be 0. Now we are going to bring their pairs together. The ones carrying a power of 2 should be paired together, and the one carrying a power of 3 should be paired together. This is s to the power 2, so let's write it there first. Now let's move this negative 2 to the power 2 close to it, so we have minus 2 to the power 2. Cool. Now this is minus s to the power 3, so let's write it down. Minus s to the power 3. Now let's move this one close to it. Minus 2 to the power 3 equal to 0. Now this is well arranged. Like I said before, we're going to be pairing them. So we're going to be pairing x squared minus 2 squared. They should be together. Minus, or we can say minus is common here, right? So bring it out. Now let's pair this. This is s to the power 3. Now, because I brought minus out, or because minus is outside, I'm not going to be writing minus here anymore. I'll be writing plus instead. 2 to the power 3. Now, close your bracket, equal to 0. Now, look at this. This is very familiar to you, right? This is difference of 2 square. And how do you express difference of 2 square? Difference of 2 square usually means when I have s square minus y square, this means s plus y, then open another bracket and write s minus y. So that's how we're going to be expressing this one. So let's do that here real quick. So this will be s plus 2 in a bracket. Then in another bracket, we'll be writing x minus 2. Cool. Cool. Now put your minus there. Now this is sum of 2 cube. And how do we express sum of 2 cube? Let me write it here. Sum of 2 cube, maybe when I have s cube plus y cube, for example, this is cube. When I have s cube plus y cube, this can be expressed as s plus y. Then in another bracket, we'll be writing s squared plus y squared minus sy. So that's how to express sum of 2 cube. So let's do that here. So we open a bracket and write s plus 2, s plus 2, cool. Then in another bracket, we write s squared plus y squared, just as it is here. S squared plus 2 squared rather, s squared plus 2 squared, then minus, when we multiply the two items, is 2s, just as it is here. Are you seeing that? Cool. So we are just following the sum of 2 cube. And that is what we just did here now. Now watch. Look carefully. You notice that s plus 2 is common. I can find s plus 2 here, and I can also find it here, right? So because they are common, we have to factorize. So bring s plus 2 out, factorize it out. So now that it is out, what are we going to have left? Here, because s plus 2 is already out, I'm going to be having s minus 2 here. S minus 2 will be remaining here, minus what will be remaining here. S plus 2 is already factorized out, so I have this one remaining, which is s squared plus 2 squared. 2 squared is 4, so let's just put it 4 there instead. So we'll put 4 minus 2s. Close your bracket and close your final bracket. Now, this is s plus 2. We have outside. Now, here, we're going to be opening this bracket with this negative we have outside. So let's do that real quick. I have s minus 2. Now, use this minus to open up the bracket. Minus s squared. Minus times plus gives us minus 4. Minus times minus gives us plus 2s. There you have it. Now, let's try to simplify what we have on this other bracket. So this is s plus 2 we have on this bracket. Then on this other bracket, I'll be writing the one with the highest power first. Take note. Write the one with the highest power first. And this is negative s squared. So let's put it there. Negative s squared. Cool. Now, this is s. And this is plus 2s. So s plus 2s gives plus 3s. Now, what is remaining? This is negative 2. And this is negative 4. So negative 2, negative 4 gives negative 6. Cool. Now I have forgotten to, always equate everything to 0 because that is what I have. Please don't forget to equate what we have to 0 because that is what we have here. Now we have two factors. We have this on this bracket and we have this on the other bracket. Now we have to get this one out. So s plus 2 is equal to 0, which is this one on this bracket is equal to 0, or this one we have here on the other bracket, which is negative s squared plus 3s minus 6 is equal to 0. Now we're going to be having our first root from this first expression. So how do we do that? So this becomes s. Now when you move plus 2 to this other side, it becomes negative 2. So this is our first root of s. Now we'll get 2 roots from here. This is a quadratic equation. And we're going to be using the general formula to solve this quadratic equation. So let's do that real quick. That means I'm going to be choosing a. What is my a here? A is negative 1 because that's the coefficient we have here. Negative 1, and b is equal to 3, positive 3. Yes, then c is equal to negative 6. So this is what we use to solve. And our formula for solving is s equal to, you remember the general formula, right? Negative b plus or minus the square root of b squared minus 4ac. Now divide by 2a. So this is the general formula we're going to be using to solve, to get the other 2 roots from this expression. So now let's use it. So let's substitute. Our s is equal to negative b. What is our b? Our b is 3. So put it there. 3 plus or minus the square root of b squared. B is 3. So we have to square that. Minus 4 times a. What is a? A is negative 1. So you put negative 1 there. Times c. C is negative 6. So you put negative 6 there. Cool. Now divide by 2a, which is 2 times a. A is negative 1. So s will be equal to negative 3 plus or minus the square root of 3 squared is 9, right? Cool. Minus 4 times minus 1 will give you minus 4, right? So minus 4 times minus 6 gives you 24. So let's put a 24 there. Now divide by 2 times minus 1 gives you minus 2. Very good. Now here we have s to be equal to negative 3 plus or minus the square root of, let me remove this, 9 minus 24. What do you have? Minus 15. There you have it. So divide by negative 2. If you notice, we have a negative root. A negative root usually indicates a complex number. So we can express this one as a complex number. Let's see that. So we have s here equal to negative 3 plus or minus the square root of, we're going to be putting 15, although it is negative. But how do we justify this? By putting I. Are you seeing it? Multiplying it with I outside. Now, divide by what? Negative 2. So now let's separate. We have s to be equal to negative 3 plus or minus. No, we are separating. Let's use the plus first. Plus root 15 I over negative 2. So this can be written as s equal to negative 3 over negative 2. Are you seeing that? Plus root 15 I over negative 2. So this will give you, negative can go with negative, right? Cool. Remaining 3 over 2. Now, plus times minus gives you minus. So root 15 I over 2. So this is one root. This is one root. Now, let's get the other root. Remember, I've been using the positive. Now, let's go and use this negative. Let's go. So we have s. Let me say all here. S equal to negative 3. This time we pick the negative. Minus root 15 times I all over negative 2. Let's separate. S will be equal to negative 3 divided by negative 2, which is this negative 2 here, minus root 15 times I divided by negative 2. I just separated the denominator, right? Cool. Now watch. Negative can go with negative here, right? So this gives us s to be equal to 3 over 2. Now, minus times minus gives you plus root 15 times I over 2. Now, this is the other root. So we saw that we have two complex roots for this particular question. So this is one and this is another one. Remember, we also have the s to be equal to what? Negative 2 from our previous slide. So these are the solutions to our famous question here. So we have our answers and you can see how simple it is. And I believe you enjoyed the video. Don't tell me you don't enjoy the video. And I believe you also learned something. If you learned something from this video and you enjoyed this video, please do not hesitate to hit the like button, subscribe if you haven't, turn on the notification bell so you don't miss my upcoming video. And until next time, take care.